Okay, this is the question 3 of the review worksheet. So let's look at the instruction. It says that use synthetic division to find the zeros. Write the polynomial in factored form. Sketch the function. So we are given a polynomial, but first we have something to fix on the worksheet. There's a little typo. It should be 3x cubed, not 3x squared. So you might want to fix that before we proceed. So yeah, we are just given by the question a very raw polynomial function, and it doesn't seem friendly because you have a leading coefficient of 3 right there. So what we need to do is to, based on our knowledge, we want to get as much information out of this polynomial as possible. So what we can do, well, at least we can do a few things. We can at least tell the degree. In this case, that will be a degree of 3. Since we have x cubed, we can tell the degree very easily. We can tell the sign. The sign is going to be positive. So based on these two pieces of information, we can tell that it will start low and end high, because if you watch the previous video for question 2, you will understand why. If not, what I usually tell, what I said in class was that just go ahead, imagine x being -10, and think about x cubed. So if x is equal to -10, so what would you get when you have -10 times -10 times -10? Okay, if you have -10 multiplying by itself 3 times, well, you have -1000, which is a very negative value. So that justifies why this cubic function will start from a very, very low place because it has a very negative y value. Okay, so I'm just going to leave this on the side right here so that you can keep an eye on it. Okay. We can also tell the y-intercept because the y-intercept, it's explicitly given right here, since it happens when x is equal to 0. So we know that at x equals to 8, we will have a, when x is equal to 0, the y value will be 8. So this is how we obtain the y-intercept. So the simple stuff, the simple information that we can extract is practically this, but it shows us nothing about the zeros as of this moment. So we have to think about, what can we do? Where could we start? And this is why it triggers the thought process of getting the consideration of the possible rational zeros. And if you remember that the possible rational zeros is the plus or minus, and then you have a fraction, and that it's the factor or factors of the constant. In this case will be the number 8 over the factor or factors of the leading coefficient. Okay, so we have this fraction right here. And so we say, all right, plus or minus. So the factors of the constant will include 1, 2, 4, and 8. And the factors of the leading coefficient would be 1 and 3. Now, we are not asking you to list all the possible rational zeros, but on the test, we did ask you to list out all the possible rational zeros. And since like if we are asking you to list them, please list them. As of now, this is not a list. Okay. So you would make the list like this. You would say plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and then plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. Okay, that's how you compile the list and show the list of possible rational zeros. So we have a lot of numbers to see right here, and we wonder, well, which one is our possible rational zero? Okay, which one is the actual zero? So what I usually suggest is to first test out the easy numbers like 1, okay, and just to see if it works. If it doesn't, then you just keep trying. Okay, so we would test out the number 1, and we say, all right, we got 3 minus 10 and 4 and 8. Okay, and then we say, all right, let's go ahead, do the synthetic division. We bring the first number down, and 1 times 3 is 3, so we got -7. 1 times -7, it's -7, and then you add them up, you still have -3, and you put a -3 right here, that it's equal to 5. The remainder is 5. And just a side note that when we have a remainder, this remainder right here, it's also telling us the function value when x is equal to 1, okay, then the function value, or the y value, it's equal to 5. Okay, the y value, it's equal to 5. So it's not a zero, unfortunately, because we have a remainder, but we can at least get something useful, which is that when x is equal to 1, then we have a function value of 5. So since we got the value, may as well plot it there. So 1 is not a root, is not a zero. So so we have to keep trying. So we say, what could work? What could work here? So we'll say, let's go ahead, try 2. And since I'm running out of space, I'm going to use the space in the right bottom corner. So 3, -10, 4, and 8. So bring the 3 down. 3 times 2, it's 6. You add -10 and 6 together, and you have -4. And -4 times 2 is -8. That gives you -4. -4 times 2, it's -8. And yay, we got a remainder of 0. That means we have a root right here. Okay, the root, it's 2. And if I want to change it back to a factor, it is x minus 2. Okay, so keep that in mind. So we have a point right here at x equals to 2. So in that case, we would say that the original function, which is 3x cubed minus 10x squared plus 4x plus 8, could be written by x minus 2 times, okay, and that's how we translate the quotient right here into the quadratic expression, 3x squared minus 4x minus 4. Okay, so now if you wonder, like, how do you know if it's x squared? Okay, if you have that question, then I would say, well, this is x cubed, right? So so x times x squared, that's how you get x cubed. Okay, that's one way to think about it. Or the other way to think about it is that since you have an x cubed divided by x minus 2, so the power should be 1 less as a result. So so that's one way to think about it. And then we say, well, can we actually factor the quadratic expression? Okay, the answer is yes, we can do that. And so 3x squared must come from 3x times x. And now the question is, what are we going to put in the as a second number inside the parentheses? Because we have a number 4 right here. And we can have 1 times 4, 4 times 1, or 2 times 2. And since the sign right here, it's a minus, that adds a little bit of a complication, because we need to also decide which one is a positive, which one is a negative. So the best way to determine it is that if you have a -4 right here, okay, if you have a -4 right here, that means you gotta do the FOIL, and the first, I mean the outer and the inner, they have to add up together to give you -4x. So you can do the trial and error, but But what you will find out is that it will have to be 3x times -2, which gives you -6x, and then plus 2x, then it gives you the -4x. Okay, so so we can condense the expression a little bit so that we can make a graph easier. So the roots are 2 and you look at this one, this is the factor. So the root, it's by setting this equal to 0. And we say, well, you have 3x equals to -2, x is equal to -2/3. Okay, x is equal to -2/3. And that's how you will obtain the other root. Now, it's very important that you understand the idea of multiplicity. So what you see here is that our root of 2, there's a square, okay, outside the factor x minus 2. So that means the root 2 would be a double root, or in other words, it has a multiplicity of 2. It's very important that you know that can interpret the multiplicity, and based on this interpretation, you know how it behaves on the graph. So we say, all right, so we have a couple points right here, and so it starts low, and it's going to go up like this, and then it's going to go all the way up, passing through 8, and then coming back down, and at x equals to 2, it's a double root since you have a square right here again. So that means it's going to bounce. And that works out perfectly because we anticipated that the graph is going to start low and end high. So that's how the graph is drawn and how you get the perfect sketch of the graph. Okay. Some common problems that I've seen when I was grading the test was that some of you still do not know how to interpret multiplicity and how to translate the multiplicity into the whole graphing process. Some of you just disregard the multiplicity and just going through the x-axis, whatever you want. That's not the case. The whole reason why we want to have the factored form, and in class we talked about how we love the factored form because it gets us the easy way to draw a graph. Okay, so so this process, it's a little bit tedious. Okay, it's a little bit tedious, but you just have to keep trying, just kind of work fast, be very familiar with synthetic division and knowing how to interpret the result of the synthetic division. Since you want to have a factor, and to be a factor means that there should not be any remainder. The remainder must be 0 if it's a factor. So, and on the other hand, I've seen people mixing up the idea of roots and factor. So that's why in class, I've been bugging everybody that if you know the root, what is the factor? If you are not fluent in translating in between roots and factors, that's going to be a major obstacle for you to succeed in this kind of problem. So again, just to review again what this problem is about, we are asked to write this polynomial into a factored form of expression. Without having much idea to begin with, we just have to start from scratch. So we just say, all right, what can we tell? We can tell the degree, we can tell the sign, we can tell the y-intercept. But those are not enough for us to find out the factored form. Those are not enough for us to sketch the graph. So we need to know something about the zeros. So that's why we started considering the possibilities of all these numbers. Okay, so we look at the possible rational zeros and we say, all right, these numbers are good. So let's go ahead, try one at a time. And we just try one and it doesn't work. And then I just try two. Okay, now, can you say, can you try -1? Yes. Okay, can you try -2? Yes. But I mean, I'm just lucky. I'm just lucky to get the right try at the second attempt. Okay, so so if you don't get it right, just keep trying. We are not gonna trick you guys by not giving you a rational zero. Okay, but it may or may not be the zero at your first shot. So just go ahead, keep trying based on something easy, and then you work your way up, up the ladder of difficulty. Okay, so that's how you will complete this problem, and your fluency is going to be very crucial. Knowing what to think. So try to walk through the thought process. Okay, look at the blank problem again. Can you hear your thought process? Can you hear yourself voicing out the strategy, the reason why you take each action along the way? That's really the best way to guarantee yourself knowing how to do this problem at any time. Okay.